I hope you're having a great conference. I hope you had a nice lunch. So my name is Ricardo. I'm going to talk a little bit about reliability. So I'm not going to talk about SRE. I'm going to talk about reliability in general. And if you came here to actually, for me to tell you what does it mean to be reliable within your context, you'll be highly disappointed. I'm not. I'm here to talk a little bit about how can we define, measure, provide a framework on how to measure and define reliability, but it will be up to you to actually define within your own context what reliability means. And a lot of this talk will be highly contextual. It will depend heavily on your actual reality, what reliability means. It's a lot about that. And so what do we have on the menu for today? So we'll start by contextualizing what reliability can mean. And for that, I'm going to use two examples. I'll start with an example from the real world. So something that we use regularly. We'll be amazed by the example that I'm going to use, so prepare to be amazed. I'm then going to translate this to our reality, so the reality of a company that builds services. I'm going to use my own reality, my own company, to what do we do and what does it mean for us to be reliable, so to speak. We will then go through a series of concepts that will help us define what reliability means and how do we define it, how do we measure it, and what we do with that. And then we'll see the real value of defining that reliability. When we have that framework, when we have that defined, when we have that measured, what we actually can do with it and how can this improve operations. And at the end, we're just going to conclude on why this is important. So the real amazing and dazzling example that I'm going to use is a supermarket. So I assume all of you have been to a supermarket. So if we think a little bit about it, a supermarket is like a microservices architecture, right? We go in, we gather some stuff, we pay, and we get out. But underneath that, there's a lot of stuff that needs to happen for that to be a reality, right? So I get in, I get some products. So someone had to put those products there. Those products have to be unloaded from a truck into the supermarket. Someone had to put an order to get those products into a truck. If I go into the butcher stand, for example, there's meat. How did that get there? If I go to pay, there's someone there or some machine that is there that had to be set up. So a supermarket is like a real-world example of some sort of a microservice architecture that all has to work in unison so that everything functions. So in this context, what does it mean to be reliable? It can mean a lot of things. We're going to use two examples to do this. So one example. So I do my shopping, I go out to pay. In this context, what can reliability mean in this specific context? It's taking too long to pay. So I can assess that the supermarket is not being reliable enough if it's taking too long to pay. So if I do my shopping and it takes 30 minutes just for me to be able to pay, I might consider that to not be a reliable service. Another example, I go into a shelf, I pick up a product expiration date has passed. So I might consider that the supermarket is not being reliable enough if I'm trying to buy stuff and all the product expiration dates have gone. So I can't actually buy, so I'm not doing what I'm supposed to do at that place. So let's start to translate this into our own reality where we develop service. So for example, if something takes too long to pay, we can translate that to a latency of an API, right? If a request or a set of requests takes too long, I can say that my system is not being reliable. And for example, the product expiration date has passed can be an error, right? We do an API call, it returns an error, so it's not doing what the users are expecting us to do. So going a little bit further and contextualizing this into my own reality, but it could be your own reality. So I work for a company called Anova. Marketing is actually going to kill me because this slide with numbers is slightly outdated. But what we do is we operate in the industrial IoT space. We gather a lot of information from industrial sensors. We process and store that data, and then develop applications on top of those. So this is a very simple explanation. We process data, we gather data, we process it, we store it, and then develop applications that can help both consumers and businesses to actually deliver service to our customers. So, and we actually offer a lot of stuff to our customers, and we do a lot of guarantees for our servers. So what does it mean in this reality for us? So it can mean that we need to provide low latency for our customers, that the data is actually accurate. So there's a lot of stuff in this set of things that we are describing that we do to our customers that actually makes our platform reliable or not. And many of those are completely different from a supermarket, right? But it doesn't mean that the supermarket also doesn't have to be reliable. So reliability is just to show that reliability can mean different things in different contexts. So how do we actually define reliability and measure it? And we're going to start by our old and a definition of what reliability means. So if we go into the Cambridge Dictionary, it says that reliability is the quality of being able to be trusted or believed because of working or behaving well. Sounds good, but I like more the definition from Alex Hidalgo in his book, Implementing Service Level Objectives. And at the end, it basically distills in this. Is my service doing what its users needed to do? So in this framework, we're basically going to define reliability in the eyes of our users. So we're not going to measure like if you have a CPU spike or if a machine went down or not. We're going to define reliability if our service is doing what our users expect it to do. So we need a way to define that, and we need a way to measure that. And we're going to start by all our old friend metrics, right? So we all collect metrics, sometimes more than we should, probably. But a metric is just a measurement about the system. It makes no assumptions. It's a measurement. So a request, for example, or let's use these examples that we have here. So the amount of memory that a server is using. So it can be the time it takes for a request to be fulfilled, or the number of errors that an HTTP endpoint gave, or it can be the age of a message in a message queue. So a metric is only and only that. It's a measurement of some characteristic of our system. So what can we do with a metric? And then we come to our second concept, which is the concept some of you might know or heard about, which is the concept of a service level indicator. So it essentially is a way for us to define if a metric or the measurement some measurement that we took can be defined as good or bad. So what is a good event? So we need a way, if we look at a specific measurement, we need a way to look at it and say, so this was a good measurement, this wasn't a good measurement. So here are a few examples. So we actually, SLIs are a definition for to do that binary state. So we say that requests to a service need to be responded within 200 milliseconds. If they're not, it's considered a bad measurement. Same thing, requests to a service must not be responded with a 500 code. If it is responded with 500 code, we consider that specific measurement to not be good. And same thing, if we have messages arriving at a Kafka cluster that are older than 5 minutes, we can say that this message is not valid anymore. So it's a bad message. So we started with metrics. We now have a way to actually say, okay, every time I look at a measure, we can say that it is good or bad. But we actually need to extrapolate this into a bigger context. And that's where service level objectives come into place. So we don't want to be looking at a specific measurement. So I don't want to be looking at every single request. I want to know, for example, in the context of all my requests, how many were good and how many were bad, and react on that. So a service level objective is the definition of how many times an SLI needs to be achieved so that my users are happy. So here are examples of SLO definitions. So one example, 99% of requests to a service need to be responded within 200 milliseconds within a 30-day period. So basically what we are doing here, like we are defining a threshold and a period. This is important. We need to have a time frame for evaluation, because if not, we are going to look at our whole history and it will not be very helpful. So these are two characteristics important for an SLO. We need to define a level, so something that I define as a target, and then the period which in that target will be evaluated. And we have other examples using the previous example. So we can say that 95% of requests need to be responded with a code different from 500 in a 7-day period, or that 99.99 of messages arriving to a Kafka cluster cannot be older than 5 minutes for every day. So how do we do this? How do we create good SLIs? Once again, this will be highly dependent on your context or highly dependent on your organization, but we have a few rules of thumb that we can use. The first one, and it's the most important of all of this that is here, we need to always, always, always focus on our users. Can replace user by customer, whatever, but we always need to focus on our end users. And our end users can mean someone using our websites, or for example, imagine that I'm an administrator of a cluster or a database cluster. It can mean the services that are just connecting to my database. So, but we need to look at reliability when defining an SLO and on the eyes of our user. Our users do not care if we have 1 machine or 1,000, if 500 of them are failing or not. They are using our service and they expect a certain level of reliability, and we need to look at it from their point of view. One good rule of thumb, because we can have a discussion, okay, so do we focus on the users from a top-down approach or from a bottom-up approach? So for example, should we start at a database and then provide reliability to the service on top of that, and then on top of that, or should we go the other way around? Should we start at our end users and go all the way down? So the easiest way, or that provides most value for companies, it's to list critical user journeys, probably looking from the outside in, and then order them by business impact, and then defining SLOs that actually measure and track those interactions. We need to actually determine which metrics we need to use and SLIs that most accurately track user experience. The common examples are things like, I don't really care if CPU is spiking on a server if it's not affecting my user. So it's not really a metric that I'm going to use on a day-to-day basis to actually measure user satisfaction. Another rule of thumb, do not create too many SLOs. We can be overwhelmed, just start defining SLOs for everything. 3 or 4 should be enough for most use cases, and some SLOs can actually be combined and to track more than one thing. One important thing is to have SLO documents, and we're going to see an example extracted from the Google SRE book of what an SLO document might look like and what information it should be there. We should review our SLOs periodically. That information will also be in the SLO document, but it's the process that we every once in a while look at our SLOs, see if they are still relevant. If not, why? Do we need to remove them? Do we need to update them? Maybe the thresholds don't make sense anymore. So that should be done periodically. Probably the first few times you will need to review that quite often, but with time you will review it once a quarter or once a year. And determine SLO targets and the SLO merit. Don't try to be too reliable, and we're going to focus on that. We're going to have a back of the envelope calculation to see what would make sense to have targets for SLOs. So this is just an example. We're going to quickly go through an example of an SLO document. This was taken from the Google SRE book. So if you want a template or for where to start and then adapt to your own reality, this is an example of an SLO document. But an SLO document is essentially where you define what your SLO is. Who are the authors who reviewed that SLO to be sure that makes sense, who approved it, when it was approved, when it should be revisited again. We have a service overview. So this is what the specific service or the type of services that this SLO can apply. We then go to the part where you have the SLI and SLO definitions. So this is where we describe how the SLO is calculated. So what metrics is it using? What is our reasoning behind what are the formulas? For example, if you're using Prometheus, what are the specific queries that we are using to actually do the calculation for that SLO? And then we have the rationale. Maybe you have some explanation to give, but why are we using this? So why is this SLO used to track this or that or whatever? So it's the rationale behind that SLO. The Agar budget is a concept that we're going to see in a bit after a few slides, but it's essentially how much unreliability you are able to accept and still maintain a high level of reliability. And of course, we can have a last section where you have clarifications or caveats. So you can use this SLO with this type of service, but you shouldn't use with that type of service because of X, Y, and Z. So this is just an example of an SLO document. It's a good starting point, and then you can adapt to your own reality. So, what is an acceptable target? Does anyone want to? Sorry. Does anyone want to shout a number? I have a few examples, but whatever. Sorry. 95. Yeah. For this thing, it depends, right? It will be dependent on a lot of factors. I have here a few, but it will depend on your users. It can depend on costs. It will depend on your business. It could be like regulation. For example, imagine that you are providing services in a highly regulated space, and they actually define what that reliability means. For instance, stocks, high frequency trading, they actually have very strict definitions of if you send a request, how long it must take, or else you get a fine. It could be costs. You can say, okay, so I can't really scale my infrastructure to be faster or have more users. And it can be highly dependent on users. So you can think, okay, so this really needs to be really fast, and users really don't care. So it can affect the way that you perceive reliability. Looking at an example using a specific SLO around reliability, what does this mean to have different targets? So I'm using here the example of availability, so a system actually being down, not being available, and what does it mean in terms of how much time you can be down? Because we hear a lot talking about nines, the nines of reliability, 2 nines, 3 nines, 4 nines. So if we have 3 nines of availability, it means that I can be down for 8 hours a year. Sounds insane, right? But if I add another 9s, if I have 4, this goes from 8 hours and 45 minutes down to 52 minutes. That's to shrink, right? If I go 5 9s, I can be down for 5 minutes a year. That's, I don't know, someone makes a mess on a load balancer and you are down for 5 minutes. So what we can see here is that what seems like innocuous, just add a 9, sounds reasonable, actually decreases like crazy. But this is also has some costs. So let's do some back of the envelope calculations here about reliability. So you see a lot in the literature, and the Google SRE book talks a lot about this. And they usually say something along the lines that if you want to add a 9 to your reliability, the costs usually increase by 10, by a factor of 10. So what does this mean in an actual example? So if we have a proposed improvement from 3 9s to 4 9s, so we have a proposed increased value in availability of 0.09. So this is how much reliability we are going to improve. If our service revenue is 1 million, it means that we're going to revenue that we're going to improve by 900. So we're going from here to here, we're going to earn on average $900 more. It can make sense. It may not make sense. It will be highly dependent on the industry. Maybe we need to do this shift because of some regulation or because we want to attract a different kind of customer, but this is the expected service revenue from this kind of improvement. So this is the example that I was talking about the 10 times. So if I want to go again from 3 9s to 4 9s, this is the level of reliability. If it costs me 1 million to run, it will cost me 10 million. So to increase 0.09 in terms of reliability, it will cost me 10 million. On a smaller scale, this might seem like a lot, but start thinking when you have 4 9s and you can only be down 22 minutes. This means that probably starting at this level, you'll have to considering like multi-region, multi-cloud provider, multi-DNS, things like, I don't know, you're using GitHub goes down, you have a bug, you can't deploy code. So everything at this level, starting from 4 9s and up, there's a lot of redundancy, so costs can quickly creep up. So, like we were talking previously, the error budget is essentially what is left from the SLO. So if I define a target of 99% of reliability, it means that I have 1% of unreliability, right? So like we describe here, it's effectively the percentage of reliability that we have left, and it will help us make it educated guesses or if we can or cannot deploy, for example, a new feature. So it helps make sure the operability process, for example, incident response, is appropriate to the level of budget that we have left. So this, we can use error budget to guide us in terms of our operations. Do we need to react? We don't need to react, whatever it is. And probably the most well-known of this reliability stack is the concept of SLAs. Everyone has heard about SLAs. And essentially, an SLA is an SLO with some form of penalty. So here are an example. So if we use the previous examples that we use with an SLO, we just say, so we need to provide 99% of requests within 20 milliseconds in a 30-day period. If not, the client will get a 30% discount, for example. Or it will get 50% of its money back. Or we're going to be fined $100,000. So an SLA is essentially an agreement that you do with your customers, mostly in highly regulated, or if you provide business to business, this is common practice. If you subscribe to a cloud provider, they actually provide you those kinds of SLAs. So for example, you're using EC2. If an EC2 is down for more than X minutes per hour, Amazon will actually make you a discount on your instances. They are usually looser than SLOs. What does this mean? It's, for example, if I have an SLI of 95, I usually have an SLO that is tighter, so that if the SLO is breached, the SLA is not, and I can do something about it before the SLA is actually breached. So what can I do with this? So now that I have a way to actually define, measure, I can actually start building interesting stuff on top of this. So one of the things, the most common things that we usually do is like have visualizations of what this looks like. So this is an example built with SLOS, which is a tool that looks at the definition of an SLO and integrates with Prometheus. So you have a definition of an SLO. It actually does queries from provides a Prometheus queries and actually builds some dashboards that are very interesting for us to measure. So basically, here we have our objective. If it's currently burning, so maybe there's some errors and we are actually burning our error budget. How much of the error budget do I have left within a window? If I have alerts triggered or not. So this is a nice way for me to have a visual way of actually looking and say, okay, is my SLO okay? Is it not? Do I need to do anything? But I don't want to be all day looking at dashboards, right? No one, unless you're working in a NOC and it's your day-to-day job, you don't want to be all day looking at the dashboard and seeing if things are good or not. I actually want to be alerted if something is not. So building on SLOs and this reliability framework, we can start building alerting that's a little bit more interesting than just alerting on metrics. So the traditional way that we alert on metrics is we have some kind of threshold. If that threshold is passes, we get an alert. So CPU is more than 80%. We got a message, a Kafka message that took that is older than 5 minutes. Of course, this can be combined to be a little bit more sophisticated. If a CPU is above 100% and requests have more than 200 milliseconds, I want to receive an alert. But we can do better. So with having SLO thresholds, we already have a definition of what it means to be reliable or not. So we assume that we can have a certain amount of reliability, and we only want to get alert when that reliability reaches a point that is not good for our customers. So it is better, but I will only be alerted when I'm in trouble. So if I assume that I have 1% of unreliability that I allow, when I burn that 1%, I'm already in trouble. So my users are already saying, okay, something is not okay, this is unacceptable. So we can extend this a little bit further. So we can build alerts on error budget available or error budget burn. So basically the idea here is that instead of looking at the target of my reliability, I look at the amount of unreliability that I have left. And I can actually build different alert channels for this. So if 25% of my available error budget is burned, I can send an email. If 50% is gone, I can send a message in Teams or Slack or wherever your platform is, say, okay, something is wrong here. I only have half of my error budget available. And if 75% of error budget is burned, I can send like a message to PagerDuty or Opsgenie or wherever it is. It is better, but I have no clue how fast my error budget is being consumed. I only get an alert, so half of it is gone. I don't know if it's gone in 1 minute, 1 hour, whatever it is. And I have a question. Say that I have an SLO that it's defined for every 24 hours or for a week or 30 days. If I know that at the end of that period, I will still have some reliability left, so this means that it's the level that users are still happy, do I want to receive this alert or not? And you can answer. Do you still want to receive an alert if your level of reliability is acceptable? You can see that on visualizations. Do you want to be woken up at 3 a.m. in the morning if you know that at the end of the month you will be okay? Again, it depends, but for the most part, you probably wouldn't. Or maybe you want to tone down. So maybe you want to just receive an email in the morning, you arrive at the office, and okay, everything is fine, I'll get a look at it. But you can play it. But the way that this is set up right now, you don't know. Because you won't receive an alert when the threshold for available error budget is burned. So can we go beyond this? Actually, we can. And here we come to the concept of error budget. And in the SRE book from Google, there's a way to actually calculate this, but error burn rate is essentially how much error budget I'm burning. And the value of 1 means that within my defined period, let's say 30 days, if I'm burning at a rate of 1, when I reach those 30 days, all of the error budget is gone. But that's fine, that's like the ideal. So you can play, you can launch more risky features because you're burning at the rate that the users are still happy. That can mean, I don't know, X amount of requests that can be over a certain latency, for example. And so here is an example. So for the window of evaluation, for example, 4 weeks, an alert, it will, if we have 2, this means that I will burn all my error budget in half that time. So it will mean that after 2 weeks, I will have no error budget. Probably I should do something at this point. It's better, but still has a problem. If the error budget burns too fast within my period that I do evaluation, I might not even receive an alert. So here's an example. If I evaluate my error rate every hour to see where I'm at, so going into metrics, and I consume everything in 30 minutes, I will receive no alert. So we can still improve on this. And this is where the multi-window, multi-run rate alert comes in. So it's very similar to the concept that we've seen before, but now we have one that tracks fast changes and one that tracks slow changes. So this is the idea. So I have a fast burn that alerts on sudden changes. If I don't know, if I have a spike on users that suddenly came into my system and my system suddenly is starting to come slow, fast burn will pick it up. But I can also have slow burns. So I have like a memory leak or something that slowly creeps up and starts to make the system, for example, slower or giving more errors. So, and here is an example. So for the fast burn, I can consider periods of evaluation of 5 minutes. I have a window of 2 hours, so my alert looks at the last 2 hours, and if the burn rate for those 2 hours is above 10, I know that something is wrong, really wrong. And the slow burn can do the same thing with a larger period. So I look, instead of looking at 2 hours, I look at 24 hours, and if the burn rate is to 2, I know that something is wrong. And this, of course, will be highly contextual and will highly depend on your context. But this is a nice way that I can actually be alerted only when things are going south. So it's not when they are already bad, but I can actually have some kind of intuition and say, okay, something is wrong. I know that there's going to be trouble, and I need to do something right now. And the last concept that we're going to see is the concept of an error budget policy. This is, for me, at least for me personally, it's one of the most interesting concepts because it's, sorry, it builds on top of everything that we've discussed previously, and it's actually a pre-definition of what will you do when you have trouble, right? So this is something that we see a lot on literature, is saying, okay, if all my error budget is gone, I won't deploy any features. So this is the most common example. And again, this will be highly dependent on your context, but it's a definition of what do I do if X or something happens. And this is very interesting because this involves the whole company. It will involve business, it will involve security, it will involve developers, operations engineers, whatever, in defining what this means, right? And it will have whoever is on call or whoever are the operations engineers to actually know what to do when something happens. So if I define here, for example, if the service exceeds all of its error budget for a 4-week period, we'll halt all changes. Only P0s will actually be deployed. It's predefined. Same thing, if I have a single incident that consumes more than 20% of my error budget, then we must do a post-mortem, for example. These are things that we define previously to things happening. So if this happens, we will do this. If that happens, we will do that. And this is very powerful. Of course, you will get into situations where some of this needs to be overruled for business decision or for business things. One common practice is to have what is called like silver bullet, but that needs to be bounded. So let's imagine that you have a definition of what is the error budget policy, and you can say to business, okay, but you have 3 silver bullets a year, so you can override whatever is in here. It can be business, can be a product owner, it can be a VP, whatever that you have. For 3 times a year, you can override what is in here, and that can also be defined in the error budget policy. You can overrule this, but you have to, for example, provide a document that justifies why this actually needs to be done, blah, 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 blah. But that can only be defined in the error budget policy. That should be documented and made available so that everyone knows exactly what to do. So to recap what we've been discussing, so we started with metrics. So metrics are just measurements about stuff. With metrics, we can build SLIs. So SLIs will help us know if a measurement that we took is good or not, or good enough in our context. SLOs mean how many times this SLI has to be good so that my users are happy. Error budgets is how much is left. So if an SLO says how many times, this is how much unreliability I can actually have. With SLOs, I can build visualizations. I can see how reliable am I. I can do alerting. Alerts can trigger my error budget policy. So if I have an alert because my error budget is being consumed, I have a policy that tells me, okay, in this situation, I have to do this, that, and that. Usually, error budget policies also influence SLAs, and SLAs are tied to SLOs, which are nothing more than an SLO which has some kind of penalty. So why is this important? Why is this useful? So for starters, we start to define reliability from the point of view of our customers, users, whatever, the way you want to define it. So instead of having arbitrary metrics or things that we take out of so many times we don't know where, we actually assess reliability from the point of view of our users. So it's our users that say, okay, your system is being reliable or not. We already have that, so we have ticketing systems. Users say, okay, your platform doesn't work or not. We're just defining a way that we can actually track that, measure, and react on that. It also creates a shared language to talk about reliability. So we have a framework, we have a way that developers, operations engineers, business people can actually talk about it, what it means for the system to be reliable. We don't have SRE saying, okay, the system is unreliable because X, Y, or Z, or developers saying another thing. Everyone speaks the same language. This means that reliability ties directly to business goals. We know that users pay for the business. If we know how happy the users are, we know that it's a direct relationship between reliability and business goals. Sorry. And of course, it facilitates prioritization. If I have error budget left, I can do more risky things, do more deployments, do changes to my infrastructure. If I have no reliability left, it means that I really need to focus on reliability. And this can mean a lot of things. This can mean that I need to do more tests, or I need to improve my deployments, whatever that means. But it helps make this distinction. If I have a lot of reliability on my system, I can do riskier things or not. And I want to end with a shameless plug. It's not so shameless because it's directly related with this talk. I'm writing a book about SRE patterns and SRE anti-patterns. It's a way to actually identify some SRE anti-patterns that teams can fall into. And one of the chapters of the book is directly related to this. So it's actually focusing on reliability on the eyes of of the users. It will talk a lot about what we've seen here, but more in depth, how we go about it, how we advocate for reliability in our systems, how can we spread this mindset within a whole company. It's already, we are already working in the process of writing, but it will be by the end of the year, should be released. And thank you very much. Hope you enjoyed it. It was informative to all of you. I will be here if anyone has questions, and I'll be at the conference until the end of the day. So don't hesitate. Come talk with me. I'm happy to discuss whatever is in this talk or whatever tech-related issue. Thank you very much.